Okay, so for this video, we are going to discuss the paper 1 with the variant paper 1-3 for May, June 2021. Okay, so for question number 1, there's a curve with this, and then the f prime x is this expression. So it's given that the curve passed through the point 2, 7, and they want us to find out the fx. Okay, so to find the fx, generally we need to do the integration. All right, we need to integrate the f prime x, where I will rewrite become minus x power -2 for this second term here. And after that, integrate. So power plus 1 divided by 3. -2 power plus 1 also become -1. So divided by -1. Then plus c, that's the constant term here. So if I try to simplify it, then I will have 2x power 3 plus 8 over x and plus c. So this is the point given, and we know that x will be the 2, y will be the 7. Therefore, we will substitute the point to the equation to get the value of c. All right, so I will substitute it. So 7 equals to 2 power 3 plus 8 over 2 plus c. So from here, if we try to simplify everything, we'll get c equals to -13, and therefore the final answer for fx will be 2x power 3 plus 8 over x minus 13. Okay, so this is how we actually get the answer for the fx. Okay, so for question number 2, they give us the function fx, and then it is telling us that the value of x should be from half until 8. Okay, so it is given that f is a decreasing function. So when you see the word decreasing function, generally you should know that the f prime x should be equals to should be smaller than 0. Okay, because when your gradient of tangent is smaller than 0, means that your original function is always decreasing. Okay, right, so they want us to find the maximum possible value of the constant a. So to find the constant a, generally we should use this information given here, like f prime x smaller than 0. Okay, so first we need to do the differentiation for function fx first. Okay, so this is my function fx. All right, so to find out the differentiation, 1 over 3 is a constant, I just copy, and then the 3 over 2 is a power, so I put it in front. Copy the bracket 2x minus 1, then the original power minus 1, and therefore I have half. After that, I need to differentiate the thing inside this bracket. Differentiate 2x minus 1, I get a 2. Okay, then after this, I will differentiate the second term here, -2x. After you differentiate, you have -2. Okay, so we try to simplify the terms. Okay, so if we try to simplify it, generally what I can see is we are having 2x minus 1 power half, and then minus 2. Okay, so by using the information given here, f is a decreasing function, therefore we can write out that f prime x is smaller than 0. When f prime x is smaller than 0, I substitute the function f prime x that we get just now. Okay. And then I square both sides to get 4. 2x smaller than 5, and from here I will get x smaller than 5 over 2. So when they mention that our answer is x smaller than 5 over 2, if you try to compare it with the domain given, so you can see that this part is actually tallying with this part where a should be equals to 5 over 2. All right, so this will be the maximum possible value for the constant. Okay, so question number 3. We are given a line with this equation, and they tell us that it is actually the tangent to the curve. Okay, for this equation. All right, so they want us to find the possible values of constant m and the corresponding coordinates of the points at which the line touched the curve. Okay, so here we see the keyword tangent to the curve, and also they actually want us to find the coordinate at where the line touch the curve. So generally, you can imagine that when they are mentioning about the curve, the parabola, and we are having a line which is a tangent. So it will look something like this. Okay, so now it is like a intersection point. There's an intersection point, okay, between the line and the curve. So to find out the value of m, we try to solve it simultaneously first, where y equals to mx minus 6, and also the curve equation is actually x squared minus 4x plus 3. Okay, so we will let 1 equals to 2. Alright, so we are having mx minus 6 equals to x squared minus 4x plus 3. So if I rephrase everything, I will have negative 4 minus mx plus 3 plus 9, which is a 9, or plus 3 plus 6, which is a 9, and that equals to 0. Okay, so from here you can see that actually I get a quadratic equation in terms of x and m. Then by using the keyword here, it is the tangent to the curve. So if you look at this situation, you can see that there's only one intersection point when the line is the tangent to the curve. So the line and the tangent has only one intersection point, which means that we can try to link it with the b squared minus 4ac should be equals to 0 because there's only one intersection point, right? So negative 4 minus m squared minus 4ac equals to 0. Okay, so we try to expand it. So we are having 16 minus 36. Okay, rephrase everything again. Alright, so we are having m plus 10, and then m minus 2 equals to 0. Then m equals to negative 10, and also m equals to 2. Alright, so this will be the values of m that we have. Okay, when the line is actually a tangent to the curve. Okay, so we already find the constant m values. Then next, they actually want us to find out the corresponding coordinate. So corresponding coordinate means that what's the value of x and y, okay, when m is equals to that particular value. Alright, so we will start for the first part first. Maybe we are taking out the first value for m when m is equals to negative 10. We will try to substitute it into this equation. Okay, so that after I substitute the value m, then I can try to solve the quadratic equation to get the value of x. So when m equals to 10, negative 10, sorry. So for this particular equation here, substitute m equals to negative 10 here, you will get the quadratic equation, which is x squared plus 6x plus 9, which is equals to 0. So if you try to factorize it, you should have one value of x only. Okay, because we already know that it is actually a tangent to the curve, so that's why you should have only one value for x, okay, for each value of m. So x plus 3 equals to 0. Therefore, you're having x equals to negative 3, and substitute x equals to negative 3 into the equation y, or this one also can, up to you. Alright, so the value of y will be equals to 24. So our first set of answer will be when m equals to 10, the coordinates will be equals to negative 3 for the x, 24 for the y. Okay, so this is the first set of the answer. Okay, for the first value of m. And after that, how about for the second value of m? So when the m is equals to 2, again, I will substitute into the equation here. So what we have is x squared minus 6x plus 9 equals to 10. Equals to 0. So I do the same thing where I try to factorize it. And from here, I'll get the value x equals to 3. Again, substitute it into the equation y. So you'll get the value y equals to 0. Okay, all right. So again, for the second set of the answer, it will be when m equals to 2, the coordinate for the line that intersect with the curve at one point is 3, 0. Okay, so we are having two sets of answers. Generally, one set, well, when m equals -10, the coordinate will be -3 and 24. The second set of the answer will be m equals to 2, and then the coordinate will be 3 and... Okay, so question number 4. They want us to show that this equation can be expressed into this form. All right, so maybe we can start from what we have here. So tangent plus sine divided by tangent minus sine equals to k. All right, so because I know that when I look at the final answer here, there's no more tangent. So that means I should try to change the tangent into the sine over cos. So this is the identity for tangent, where tangent x equals to sine over cos. Okay, so next step, because of the cos x, as the denominator is very troublesome for us to simplify it, therefore I would like to make it disappear by multiplying the top and bottom with cos x. Okay, so when I try to multiply them, my equation will look something like this. It will become sine x plus sine x cos x, and also sine x minus sine x cos x equals to k. Okay, then from here, I realize that I can factorize out the sine x from the top. So I'm having 1 plus cos x. I can do the same thing for the denominator as well. So I also factorize out the sine x, and therefore I have 1 minus cos x. And it is equals to k. So from here, you can see very clearly that I already get the equation that they want us to show. Okay. All right. So now we can go to part 2, part B. Okay. So for part B, they want us to express cos x in terms of x. So that means I need to rearrange my equation from here into the equation where cos x equals to something something k. So I can continue from the answer that we stop here. Right. So I multiply the 1 minus cos x over with the k. So I'm having this. Okay, so cos x plus k cos x equals to k minus 1. I can factorize out the cos x so that I can keep it on the left hand side later. Okay, so cos x can be written as k minus 1 divided by 1 plus k or k plus 1. All right, so this is what we have for cos x in terms of k. And now we can proceed to part C. Okay, so for part C, they actually want us to solve this equation where the x is from negative pi until positive pi. Okay, so for this equation, generally if you try to compare it with the equation that you have in the first part, you can see that they are exactly the same, and the k is actually equals to 4 in this case. Okay, and when we want to solve this equation, we can use the simplified equation that we get just now, where cos x is equals to k minus 1 divided by k plus 1. Because this equation, after we prove everything, right, we actually lead to this one. So we can use this equation in a simple version, right, to solve the equation, to solve it, okay, to solve for the x. So I will start from here straight away. Okay, so since I know that cos x is equals to k minus 1, and in part number C, the k is actually 4. So 4 minus 1, you get a 3. and 4 plus 1, you get a 5. Okay, so we would like to actually solve this equation from negative pi until positive pi for x. So first, you can find out the basic angle first. So the basic angle actually will be cos inverse 3 over 5. Okay, and then to find the value of x, for cos positive, we accept the answer from the first quadrant. So from the first quadrant, it will be 0.927 in radian form, okay, in the unit of radian. And we also accept the fourth. Okay, so this is the quadrant that we accept, and then we also accept the fourth quadrant, but we have to measure it in the negative angle, which is in clockwise direction. So if you measure it like this, we are having it negative 0.927. So this will be the two answer, okay, for part number C. Okay, so for question number 5, we have a diagram with the triangle ABC, and then the angle ABC is 90 degrees, and it is given that AB equals to 4. So the sector ABD is actually the part of the circle with center A. The area of the sector is 10 cm squared. This is the area of the sector, right? Okay, so first they want us to find the angle of BAD in radian. So to find the angle BAD, I think I will use this information where the area of the sector is equals to 10. So the area of sector is equals to 10. Okay, so what is the formula for the area of sector? It will be half r squared theta. So in this case, the theta I am referring to the angle of BAD. Alright, so it is equals to 10. So from here, very easily you will get the answer, okay, for the theta, which is 10 divided by 8, and you'll get 1.25. Okay, so we can mention that the angle BAD is actually equals to 1.25 radians. Alright, then now let's continue to part B. Okay, so maybe for part B, I try to put it here. Okay, it is 4 marks. Right, so for part B, generally they want us to find the perimeter of the shaded region. So to find the perimeter of the shaded region, you need 3 different sides here. One of them is the arc of BD, another one is the length of BC, and also the length of DC. Okay, so before I can find out all the answer here, generally I try to find out BC first. Okay, so to find the BC, I can use the information from this triangle where the tangent of 1.25, the tangent of the theta, should be equals to BC over 4. So I can actually express the BC in 4 tangent 1.25. So I'll keep this first. Okay, and after that, I want to find the DC. So before I can find the DC, maybe I want to use is I use the cos 1.25. So the cos 1.25 will be equals to the adjacent, which is the 4, over the hypotenuse. So the hypotenuse is AC. So instead of writing it out as AC, I write it out as 4 plus DC. So it is equals to 4 plus DC. Okay, so from this particular equation, I will eventually get the DC in this form. So DC equals to 4 cos 1.25 minus 4. I'll keep this to be used later, right? Then I can start to find out the perimeter already. So the perimeter of shaded region. Okay, so like what I mentioned just now, there are 3 parts. The first one is the arc BD. So the arc BD will be r theta, which is 4 times theta 1.25. Then plus the length of BC. So I substitute 4 tangent 1.25 And also the last part is the length of DC. And again, I will try to put in the length of DC in our calculation. Alright, so from here, by pressing calculator and without doing any careless mistake, you should get 25.72370947. Please make sure that you keep your calculator in the radian form. Alright, so because all these are measured in radian, okay, then correct it to 3 significant figure, I will have 25.7. Okay, so now we discuss question number 6. So we are given two functions. Okay, so we are having fx and also gx, and the function is given like this. So by first expressing each of the fx and gx in completed square form, okay, so we need to rephrase our f and g function into the completed square form. And after that, we need to express gx in the form of this, okay, where p and q are constant. All right, so let's start with by changing so by changing the function fx into the completed square form first. All right, so our b will be -2. So b divided by 2 will be -1, right? So I will plus -1 square, and then minus -1 square, then plus 5. So I combine the first three terms together. I'm having x minus 1 square. Okay, then minus 1 plus 5. So from here, I will have x minus 1 square plus 4. So this is the completed square form for fx. Okay, then after that, we try to complete the square for gx. Okay, so we are having x squared plus 4x plus 13. And then our b here for this function g is actually the 4. So we are having x squared plus 4x. We take the b divided by 2. So we are having 2 squared minus 2 squared, then plus 13. Okay, and after that, we try to simplify the first three terms, become a big bracket, then minus 4 plus 13. And from here, we can see that the answer that we get will be x plus 2 squared plus 9. Okay, so this is the completed square form for gx, and they actually want us to rephrase it in the fx pattern. Okay, so we have to actually try to compare. Like for this one, fx is -1 for x minus 1. And then if you try to compare it with the gx, it becomes x plus 2. So from fx to gx, generally you need to plus 3 for all the x, so that x minus 1 plus 3, then only you'll get what we have here. Okay, x plus 2 in gx. Then we look for this value 4, and then if you try to compare with the value in gx, it will be the 9. So that means from 4 become 9, we actually need to plus 5. All right, so if you try to compare these two functions, generally you can see that gx can be written as fx plus 3. That means we plus 3 inside the bracket for the function, and also plus 5 outside the function. So this is what we have. Okay, g can be written as fx plus 3, then plus 5. Okay, then now we go for question number B, part B. Right, so for part B, they ask us to describe fully the transformation which transform the graph of fx to the graph of gx. Okay, so from fx to gx, you can see that we actually go through with two translation, one in x direction, another one in y direction. Okay, so you can choose okay, which one to start first, also no problem. Okay, you can start with the y translation first. You can also start with the x translation first for this case, right? So let us start. So there's a translation in x direction, okay, of having 3 units to the left hand side. And after that, we also have the translation in the y direction. Okay, so we are actually moving it 5 units up. So 5 units moving up. Okay, so this is the transformation that we have, okay, which you can see that both are actually translation. Okay, so one is the translation in the x direction, another one will be the translation in y direction. Okay, so for question number 7, they want us to write down the first four terms for the expansion for this bracket. Okay, a minus x power 6. All right, so first four terms. First four terms means that we are having starting from the term starting from 6c0 lah. So 6c0, a power 6, negative x power, 0. Then plus 6c1, a power 5, and then negative x power 1. So I think at first you need to know how to apply the binomial expansion formula correctly. Okay. So until the fourth term. So fourth term is include until x 63 lah. So a power 3, negative x power 3. Okay, so if you try to press the calculator and you didn't do any careless mistake, then this is the answer that you should get. A power 6, 6a power 5x, 15a power 4x squared, and then minus 20a power 3x power 3. Okay, so by the way, this one only 2 marks will be given. Okay, so just make sure that you don't do any careless mistake to get the answer here. Then now we go to part number B. Okay, so for part number B, they told us that the coefficient of x squared in this expansion is negative 20. So they want you to find in exact form, okay, the possible values of the constant A. So you can see the word values. So that means you have more than one answer for A. Yeah, so we'll start from here first. Okay, so according to this expansion, right, I'm having 1 plus 2 over ax multiply with a minus x power 6. Okay, so what I will do is that I will try to replace the binomial expansion answer that I get in part 1. So I substitute into the part number B. Okay, and now I want to try to figure out where do I have x squared? How can I get x squared? Okay, so to get the x squared, we look at the first term of the first bracket first. It is a 1. So you need to multiply it something with x squared. Okay, so you need to multiply with this. Therefore, you'll get 15 a power 4 x squared. And after that, for the second term, it is 2 over ax. You need to multiply with something with x power 3. So that when you simplify x power 3 with the x divided by x, then you have overall answer, which is the x squared as well, right? So I need to multiply this. Okay, so when you multiply this together, you will have negative 40 a power 3 x power 3 divided by ax. So from here, if you further simplify it, then this is what you have, 15a power 4 x squared, then minus 40a squared x squared. Okay, and because of this question, they already tell you that the coefficient of x squared is negative 20. So the coefficient of x squared will be 15a power 4 minus 40a squared. Okay, so you can write like this, 15a power 4 minus 40a squared equals to negative 20. Okay, then continue further. Okay, then I think you can further simplify it. So you can divide everything by 5. Okay, so this is a quadratic form equation in terms of a squared. So you can actually try to factorize it out. Okay, so we are having 3a squared with a squared here. And then you have 2 and 2, right? 2 and 2. So that you have negative and negative. Okay, so if you try to see from here, a squared is 2 over 3. And then a squared is equals to 2. Therefore, a will be plus minus square root 2 over 3, and then a is plus minus square root 2. Okay, so you can leave your answer in this way, where a is plus minus square root 2 over 3, and then plus minus square root 2, because they're asking for the exact form. Right? So some students, they will ask whether can we change this into a rationalized fraction or not. If you want to rationalize it, also can. Okay, so if you try to rationalize it, you will get square root 6 over 3. Okay, so both answer will be accepted. For our marking scheme in this paper, right, they actually accept this square root 2 over 3. But if let's say you try to rationalize it, then the answer should be square root 6 over 3. Okay, the 3 no square root anymore, so the square root is at the 6th part. All right, so this is how we actually solve part number 2. Okay, so for this question number 8, okay, they give you the function f and g, and then you can see f is this function and then g is this function. And what is important here is you need to know that the domain given. Okay, so for function fx, the domain given is x smaller than 0. And then for the function gx, the domain is actually x smaller than negative half. So actually these two domain given here is quite important for you to answer the question later. All right. Okay, so let's have a look for part A. They want us to solve the equation of fgx equals to 3. Okay, so fgm is the composite function. You need to find out the composite function first. So fgx equals to 3. Okay, so what does it mean? That means that you need to put the gx 1 over 2x plus 1 into the function f. Okay, so that means your function f will become 1 over 2x plus 1 square minus 1 equals to 3. Okay, so of course you need to continue to try and solve to get the value of x. So what do you have here is 1 over 2x plus 1. You square the whole thing equals to 4. Okay, so when you take the square root, right? Okay, it will be plus and minus 2. Okay, then how are we going to solve it? So from here, you will see that you have two answers here, two parts of answer here. The first one, it will be plus 1 over 2. Another one will be 2x plus 1 equals to negative 1 over 2. Yeah, all right. Okay, then after this part, what are we going to have is like you try to solve, okay? So if you solve this first part here, 1, you bring it over, become negative 1, so negative half. Negative half divided by 2, you have negative 1 over 4. Okay, then for this part, you are having x equals to minus 1 become negative 3 over 2, then you become negative 3 over 4. Okay, so when you try to solve it, it looks like this will be your final answer, but generally, we have to ignore this answer. And we only accept the negative 3 over 4 as the answer. Okay, so why do we need to actually ignore the negative 1 over 4, but we only accept the negative 3 over 4? Okay, so here it is related to the domain given actually, and also the composite function that we have. Okay, so again, we try to have a look for the relationship between all the domain and range for the composite function. So g comes first, right, for g of x, then followed by f. Okay, all right. So now from here, what can we see is like for this first set of domain of the circle here, the data here, it will be domain of g. So this will be the range of g. At the same time, this is actually the domain of f also, and then this is the range of f. Okay, all right. So we have an important result here where the range of g is equal to the domain of f. So I write again, the range of g should be equal to the domain of f. Agree or not? Because we are having the composite function. All right, so the range of g, what is the range of g? So the range of g generally refer to this function. So it will be 1 over 2x plus 1. And then the domain of f, what is the domain of f? So the domain of f given here is x smaller than 0. So that means that if you're trying to link the range of g with the domain of f, right, it should have 1 over 2x plus 1. smaller than 0. And if we try to compare this result with our steps here, okay, so you can see that this is actually the range of G, correct or not? And what is the condition that we have? The range of G must be smaller than 0. So we are having two answers here, plus 2 and minus 2. So which one should we accept actually? We actually should accept one answer where it should be 1 over 2x plus 1 equals to negative 2. We only accept the part with negative 2. Therefore, this is the part that we actually ignore. So that's why eventually we ignore the negative 1 over 4, but we only accept the negative 3 over 4. So this is the reason why we only accept x equals to negative 3 over 4. Okay, as our final answer. All right, because of the condition here for the composite function. Okay, so now we come to the part number B, where they want us to find the expression for fg inverse x. Okay, so to find the fg inverse x, first I think we should find out the fgx first. So where is the fgx? Just now we already tried to find the fgx in part number A. Okay, so for your information, this is actually my fgx. Okay, so to find the inverse function, what I do is like I will let y equals to the fgx. Okay, then I will rephrase this one become x equals to something something y. All right. Okay, so I'm having 1 over 2x plus 1. I will have square root plus minus square root for y plus 1. Okay, then I will have 2x plus 1 equals to plus minus 1 over square root y plus 1. Okay, so if I continue further, I will have x equals to negative 1 over 2 plus minus 1 over 2 square root y plus 1. Okay, all right. So now, this is our step, and we actually need to decide which one will be the correct final answer for my inverse function. So if you look at this one, we are having negative half minus something. Another one will be negative half plus something. Okay, so what is the correct final inverse function that I should accept in this part? All right, so again, to get the range of the inverse function, you need to refer to the domain of the original function. Okay, your original function is fgx, and the domain for fgx is actually this one. Okay, because you start from function g first, right? Okay, so the domain for the fgx is the same as the domain of g. So if I look at the domain of g, they want to have x smaller than negative half. We come back to this question. Which one will give you smaller than negative half? So is it negative half minus something will become smaller than negative half, or negative half plus something will become smaller? So definitely it's the top one, right? Okay. So from here, you can decide that your inverse function will be equals to negative half minus 1 over 2 square root x plus 1. So this is the correct final answer. All right. So in your solution, please make sure that you always include the plus and minus sign when you want to take square root by yourself. Okay, so usually this one will be given marks. Then after that, you have to select the correct final answer by referring to the original domain. Okay, so for question number 9, they give us a geometric progression. And then they give us some important information here where the second term is equals to 24% of the sum to infinity. So the second term will be Tn, okay, equals to 24% means 0.24. The sum to infinity means S infinity. Okay, so they want us to find the possible ratio, the possible values. So again, you see the word S, values of the common ratio. So you want to find the R. Okay, so first you try to, sorry, there's a mistake here. It should be T2, second term, so T2. Yeah, so for a geometric progression, what is the formula for T2? It will be AR power 1, right? Okay, then 0.4 you just copy. For the sum to infinity, the formula will be a divided by 1 minus r. Okay, so from here you can see that you can simplify the a, and after that you can just try to move the 1 minus r up, equals to 0.24. Okay, so to factorize it later, right, so I will try to change the 0.24 into a fraction first. So if I press calculator, 0.24 will be 6 over 25. Yeah, so I'm having r minus r squared equals to 6 over 25. Then I try to rephrase everything. I'll have 25r squared minus 25r plus 6, which is equals to 0. So from here, I try to factorize it also. I'll have 3 and 2. Okay, so you'll get two values of r, where the one of them is 2 over 5, another one is 3 over 5. Okay, so this is what we have for part number 8. Okay, then now we can proceed to part B. Okay, so for part B, they tell us that there's an arithmetic progression P. Okay, so first arithmetic progression is the P, and we have the term A and common difference D. And we have another arithmetic progression which is Q, and the first term is 2 bracket A plus 1, common difference is D plus 1. So they give us some extra information here. So this two information is important because you want to use it, okay, and try to get the A and D later. So that means from here we can expect that we want to form two equations from these two information, and after that we solve simultaneous equation to get the value of A and also the value of D. Okay, all right, so let us start with the first information first. Okay, so fifth term of P. For the fifth term of P, your P first term is A, common difference is D. So fifth term will be A plus n minus 1D. n minus 1 is a 4. Okay, so 4D divided by 12 term of Q. So for the Q, you need to know that A is this one and the D is this one. Okay, so 12 term means A plus, so A is this one, 2A plus 1. This is A plus n minus 1, which is 11, and the D. So the D is actually D plus 1, okay? So equals to 1 over 3. Okay, I bring the 3 up. And also this one, I bring it up as well. Okay, so I'm having 2A plus 2, 11D plus 11. Okay, so if I try to simplify it now, I'll have A equals to 13 minus D. And this is my first equation. All right, so what you need to do is you have to make sure that you don't mix up the P and also Q because they are two different arithmetic progression. Okay, so the value for first term and the difference is different for both. Okay, then after I get the first equation already, then now we proceed to the second information. So the second information is given like this. Sum of the first 5 terms of P. So S5. S5 means n divided by 2, 2A, so 2A plus n minus 1. n minus 1 is a 4. n minus 1D. D is the D for the P. Okay, then now for the Q. Sum of the first 5 terms also. So it will be 5 over 2. n over 2, 2A. So 2A will be 2 multiply with 2A plus 1. This is the A. 2, then 8 inside. Okay, so 2A plus n minus 1D. n minus 1 is a 4 also. And the D is 4 plus 1. So this is equals to 2 over 3. Okay. All right. So again, you can try to simplify everything slowly. So 5 over 2 and 5 over 2 can be cancelled off straight away first. Okay. Then after that, the 3, I bring it up. So I'm having 3, 2A plus 4D equals to, then this denominator, I will bring it up. So I'm having a 2. Okay, so I have a look for this one first. 2 multiplied with 2 is a 4 lah. So I multiply inside here and I will have 4a plus 4. Then this one also multiply in, I will have 4d plus 4. Okay, 6a plus 12d equals to 8a plus 8d plus 16. Okay, so if I try to simplify slowly, okay, what will I get here is I will group all the a together and also all the d together. So for this part, I will have 4d equals to 2a plus 16. Okay, so you can make this as a second equation or second equation if you want. So you can see that we are trying to solve the simultaneous equation to get the value for a and b. Okay, now, all right. So for this one, maybe I can try to further simplify also, because I can simplify, divide everything by 2. 2d equals to a plus 8. Now we simplify first before we solve the simultaneous equation. Okay, all right. So I will substitute 1 into 2. Okay, so what will I have here is 2d equals to 13 minus d plus a. So 3d equals to 21. Therefore, your d is equals to 7. And after that, your a is equals to 13 minus 7, which is the 6. So this is how we solve it. So for this whole process, right, the most important thing is you don't do any careless mistake here. At first, I actually make careless mistake here also. So that's why I get the answer wrong. Okay, but you have to make sure that you substitute the correct value, then solve simultaneous equation, and you can get the answer. Okay, so let us discuss question number 10 now. Right, so we are given 3 points here, and then all of them are actually lying on the circumference of a circle. Okay, and then the center of the circle is center D. First, they want us to show that the angle ABC is 90 degrees. So to find the angle ABC, this is A, this is B, and this is C. To show that it is 90 degrees, you can actually use the gradient, all right, of the perpendicular lines, okay, to prove that they are 90 degrees. Right, so first maybe you can try to find the gradient of AB, and after that we find out the gradient of BC. Okay, then we try to use the property of the perpendicular lines. Okay, so now let's start. MAB will be equals to 0 minus 3 divided by 3 minus negative 2. All right, so we are having negative 3 over 5. And then for the gradient of BC, we are having 5 minus 0 divided by 6 minus 3. So from here, you can see that you get 5 over 3. Okay, so if let's say they are perpendicular to each other, right? If we multiply their gradient, we will get the value negative 1. So we try to multiply them and have a look. So we are having negative 3 over 5. Then multiply with 5 over 3. The answer that we get is actually a negative 1. So that means BC and AB are perpendicular to each other. So you can write like this: AB is perpendicular to BC, and therefore the angle ABC is actually 90 degrees. All right, so you need to show them, right, all the value for the gradient here. Then now we continue to part number B. Okay, so for part number B, they want us to state the coordinates of D. Okay, so here, after we know that A, B, and C, right, the angle ABC is 90 degrees. So maybe we can draw it like this. So let's say this is A, let's say this is B, and let's say this is C. So since we already know that angle ABC is 90 degrees, therefore automatically you should know that AC is actually the diameter. All right, because when you're having a triangle in the circle, and where the angle on the circumference is 90 degrees, right? Generally, the other side, the hypotenuse side, will be actually the diameter for the circle. Right, so we already know that AC is the diameter. Therefore, to calculate the midpoint D, the center D, it is actually the midpoint of AC.
Okay, so D is equals to midpoint of AC, and therefore A is -2 plus 6 divided by 2, then 3 plus 5 divided by 2. All right, so what's the coordinate for D? So from here, the coordinate for D will be equals to 2, and then this is 4. So this is how we get the coordinates of D. Okay, then continue further for part C. All right, so for part number C, they want us to find the equation of the circle. Okay, so we already have the center, and now we actually want to try to get the radius. So to find the radius, there are a few ways. You can find out the length for DC, then the length for DA, or you can find out the length for AC, and then you divide it by 2. Okay, so there are many ways for you to find the radius first. Okay, so for me, I try to find the radius by using AD. Okay, so what's the point A? Point A is -2 and 3. Okay, and then point D is this one. All right, so for my point A is -2 minus 2 square plus 3 minus 4 square. Okay, so from here we are having 16 plus 1, where the radius will be equals to square root 17. Okay, so you already have the radius, you have the center, therefore we can write out the equation for the circle. So it will be x minus the x coordinate of center, y minus the y coordinate for center equals to r squared. So you can write it becomes square root 17 square, or you can simplify it becomes 17. Okay, so this is the equation of the particular circle that we have here. Then there's another part. The point E lies on the circumference of the circle such that BE is a diameter also. Right, so that means on the same circle, now we are having the point E, and B is actually the diameter. They want us to find an equation of the tangent to the circle at E. Okay, so again, we are still having the same circle. Okay, so assume that this is the point B just now that we have. Okay, and then this is point E. So B until E is actually the diameter. Therefore, it will pass through the center D. Okay, all right. So now they want to find the equation of the tangent to the circle at E. So this is the equation. This is the tangent line. Okay, and they want us to find out this equation. Okay, so to find out the tangent at E, first we need to find out the coordinate for E first. So I let E equals to xy. All right. Okay, so if let's say A equals to xy, that means D is 2, 4 will be equals to the center or the midpoint of BE. So midpoint of BE, how we calculate it? It will be x plus 3 divided by 2. So y plus 0 divided by 2. Because just now in the first part, we already know the coordinate of B is actually 3, 0. So you can see that by using the coordinate, all right, 3 and 0, and then E equals to xy. And from here, I try to find out the value for x and also value for y. Okay, so what's the value for x here? So x plus 3 divided by 2 equals to 2. Then y plus 0 divided by 2 equals to 4. So if I try to simplify everything here, then I will have x equals to 1 and then y equals to 8. Okay, so from here I know that my coordinate for point E is actually 1 and 8. Okay, so this is one of the important information that I can use it to form the equation of tangent later. Okay, so when we want to form the equation of a straight line, right, we need two important info. The first one is the passing point. So the coordinate E is already the passing point through the line. So the second thing is we need the gradient. Right, so what is the gradient for this particular tangent? Okay, so again, we are going to use another property where when we are having the tangent that pass through the E, right, the gradient the angle from D to E, okay, and also with the tangent line will be always 90 degree. So you can see that this is 90 degree. Therefore, to get the gradient of the tangent line, I try to find out the gradient of DE first. Okay, so again, just to recall back, what is the D? D is 2, 4. So what's the E? E is 1, 8. So I want to find out the gradient of DE. It will be 8 minus 4 divided by 1 minus 2. So from here, you will get negative 4. And you should know that the gradient of tangent multiplied with this one, you will get negative 1 because they are perpendicular to each other. Therefore, you should know that the gradient of tangent should be equals to 1 over 4. Okay, so once you have the gradient and also the passing point, then you can try to get the equation of the tangent. So to get the equation of tangent, what we do here is you use that equation of tangent. Okay, so it is y minus y1, the point E, equals to m x minus x1. Okay, so from here you try to simplify everything. If you didn't do any careless mistake, then the answer that you get should be 1 over 4 x minus 31 over 4. Alright, so this is how we actually form the equation of the tangent at E to the circle. Okay, so we come to the very last question for this paper. Okay, question 11. There's a diagram show parts of the curve with this equation where k is a positive constant. Alright, so k is a positive constant here, and then they want us to find the coordinates of the minimum point of the curve, giving your answer in terms of k. So to find the coordinates of the minimum point is the keyword. So usually when we want to find the minimum point, right, we need to go through with dy dx first. So I will try to get a dy dx for this equation. Okay, so to differentiate the equation y, okay, so x power half, the power you put in front, x you copy, and then power minus 1 become negative half. Plus k squared is a constant, so you just copy the k square, and then you differentiate this one. All right, so negative half, if you should put it in front, become negative half lah. Copy the x, power minus 1 become negative 3 over 2. Okay, so if you try to simplify this, then generally what we have here is we will have 1 over 2 square root x, and then negative k square over 2 square root x power 3. Okay, and then when you want to find the minimum point, at the minimum point, right, the gradient of tangent is equals to 0. Therefore, it is equals to 0 here. Okay, so I try to simplify my equation. All right, so this is the equation that so far that I get. All right, so what I'm going to do now is I try to move all the x to one side. Okay, all the other values and constant to another side. So if I try to move it, I will have x power 3 divided by square root x. Okay, you have something like this. Cancel off the 2. And then when you are having the square root, right, on at the numerator and also the denominator, generally you can assume that there's actually a square root, one single square root here. All right, so you can also have a look at when I'm having one single square root here, then I have x power 3 divided by x. So this part will eventually become square root x squared, and it is equals to k squared. So what's the square root x squared? So square root x squared is actually the x. So x will be equals to k squared. So this is the x coordinate, okay, for the minimum point. And I want to find out the y coordinate. So to find the y coordinate, you need to substitute it back into the equation, original equation here. Okay, so substitute x with k squared. So x power half is actually square root x, and you want to substitute it by using k squared now. So square root k squared, you get a k. Then plus, okay, so you're having k squared over square root x. So again, you want to substitute the k squared, you want to substitute the x with k squared. So it will become k squared divided by square root k, which is the k. So from here, your coordinate of y should be the this part will be the k. So k plus k you will get 2k. So that's why the coordinate for y will be 2k. All right. Therefore, after you find out the coordinate already, then you can make a conclusion. K squared and 2k is the minimum point of y. All right. So this is how we complete the part A. And now we can proceed to part B. Okay, so for part B, they are saying that the tangent at the point on the curve where x equals to 4k squared intersect the y-axis at P. So they want us to find the y coordinate of P in terms of k. So they're talking about the P, and then how can we get the P here? They give us the information, the tangent at the point of the curve. So that means on this tangent line, okay, the line of tangent intersect the y-axis at P. So of course, at first, we need to try to find out the equation of tangent first. Okay, so to find the equation of tangent, of course, you need dy dx. You already get a dy dx here. In the first part, I rewrite it again. So dy dx, it will be actually 1 over 2 square root x minus k squared divided by 2 and then square root x power 3. Okay, so I want to get the gradient of tangent. So how to get the gradient of tangent? You substitute the x coordinate into the dy dx. So now I want to substitute x coordinate already. So substitute 4k squared into the x. This is what I have. Minus k squared divided by 2. Okay, then x power 3 means you can take 4k squared power 3. Then only you square root it. But in my opinion, right, if you want to simplify this one, generally it will be better if you take the square root first. So that means I want to take the square root for 4k squared first. After that, only I cube it to get the final answer. Okay, all right. So let's have a look here. Square root 4k squared, I get 2k. So 2k times 2, you get 4k. So I can write as 1 over 4k. Minus k squared on top is still the k squared. Okay, so for this one, square root 4k squared, you get 2k. So 2k power 3, you have 8k3. 8k power 3. 8k power 3 multiplied with 2, you get 16k power 3. Okay, all right. Then after that, how should we continue? So from here, again, you can put it like this. 1 over 4 multiplied with 1 over k lah. And then minus, if you try to simplify this part, you will get 1 over 16 multiplied with 1 over k. So you can assume that the 1 over k is an apple, like an apple. All right, so 1 over 4 apple minus 1 over 16 apples, and therefore you have 3 over 16 apple. So you can rewrite it like this. So 3 over 16k. And you need to be aware that this is actually the gradient of tangent. Okay, so we already have the gradient of tangent. Now we need the coordinate, okay, to form the equation of tangent. So what is the coordinate that we should use? It is given already in the question. We are concerning about the tangent at x equals to 4k squared. Okay, so when x equals to 4k squared, what is the value of y? Okay, so again, you need to refer back to your original y-axis, y equation, which is this one. Okay, all right. So, and we want to substitute x equals to 4k squared into this equation. So let us start. Okay, so to substitute, I will having square root 4k squared. Okay, and then plus, I will have k squared divided by square root 4k squared. Okay, then from here, if I try to simplify, I'm having 2k plus k squared divided by 2k. Okay, so from here, I will have 2k, then plus, I can simplify the k here, right? This one with this. So I'm having actually k over 2. Or you can write as 1 over 2 multiplied with k lah. So 2k plus 1 over 2k, you are having the 5 over 2k. So you already know that the coordinate now will be 4k squared with 5 over 2k. Right? Okay, then now we already have the passing point, we already have the gradient, therefore we need to calculate we need to find out the gradient of tangent. So the general formula will be y minus y1 equals to m 3 over 16k x minus x1. Alright, so this will look very complicated. It seems like very complicated because you have all the k lah, x and y here. Okay, but never mind. So now we already get the equation of tangent, right? But we want to focus on what the question wants us to find. So they actually tell us that find the y coordinate of P. Okay, so what is P? P means intersect the y-axis at P. So intersect at y-axis already tell you that x is equals to 0. So that means when x equals to 0, what will happen to this equation? So you have y equals to 3. Okay, so 3 multiplied with this one, what do you get? You have negative 12. So negative 12k squared divided by 16k plus 5k over 2. And from here, you can further simplify it. K and k can be simplified. And then this one is a 3, this one is a 4. So if you continue from here, you get negative 3 over 4k plus 5 over 2k. Okay, so eventually what do you get for your coordinate of y? So the y that you get will be equals to 7 over 4k. And this is actually the y-intercept that they want us to find.
Okay, so 11 part number C. So according to this diagram, we already know the equation, right? So they want us to find the shaded region. Okay, the shaded region is bounded by the curve, x-axis, and these two lines here. So they want you to find the area of the shaded region in terms of k. Okay, so to find the area of the shaded region, generally what you need to do is you have to do the integration. Correct or not? Okay, so we will start with area. Okay, so to find the area, you need to do the integration. Okay, so for this particular question, right, because you can observe that in the diagram, the area mainly attached with the x-axis, therefore we should integrate something with the x. Okay, and since it is attached with x-axis, you need to fill in the limit, okay, for the x. So this is the limit where the area start, and this is the limit where the area end. So you should put in 9k squared over 4. Then this one will be 4k squared. And you fill in the equation also, which is x power half plus k squared x power negative half. Okay, so you can start the integration. So power plus 1 becomes 3 over 2 divided by 3 over 2. K squared is the constant you just copy. So this negative half power you plus 1 become 1 over 2. Therefore, you divide it by 1 over 2 as well. Then 4k squared, 9k squared over 4. Okay, so usually for me, I prefer to simplify everything first before I substitute the limit in. Like for me myself, I don't like to have fraction at the denominator. So for me, I prefer to simplify it. So how to simplify is I change it into a proper form, which is 2 over 3, x power 3 over 2. Okay, then plus 2k squared, x power half. 4k squared, then 9k squared over 4. Okay, so I start to substitute the limit inside. Okay, so I substitute 4k squared into this part. Okay, so for this one, how are you going to simplify it? You just always remember that when you're having x power 3 over 2, right? So the 1 over 2 here is actually the square root. So that means you try to take the square root of 4k squared first. So the square root of 4k squared will be 2k. After you get a 2k, only you power it, power 3. So that's the meaning. Okay, so for 2k, once you get a 2k power 3, what do you get? You get 8k power 3. Okay, so for this part, you will have 2 over 3 multiplied with 8k power 3. Understand? Alright, so for this part also the same, you substitute 4k squared into the x. So x power half. So x power half of 4k squared will be 2k. So 2k multiplied with 2k squared will be 4k power 3. Okay, then after that you need to minus, substitute 9k squared over 4 into this equation again. Alright, so again for x power 3 over 2, you take the square root for 9k squared over 4 first, which is actually 3k over 2, and after that only you power 3 cube it. Okay, so when you cube this value, it will be 27 over 8. Okay, so if you want, you can rewrite it like this: 2 over 3, then you are having 27k power 3 over 8, then plus, substitute the 9k squared power over 4 into this part, so you have 3k over 2. So 3k over 2 multiply with 2k squared, 3k over 2 multiply with 2k squared. So from here you will get 3k power 3. Okay, so actually you can see that everything here it is in terms of k power 3 lah. So you can simplify them further. Okay, so to simplify them further, you have 16 over 3k power 3 plus 4k power 3 minus 27 over 12k power 3. This is 4, right? 4 times 3. Or then I can simplify further. Simplify it further. This is a 3 cancel. This one is a 9. So I have 9 over 4 k power 3, then minus 3k power 3. Okay, so you just press calculator. 16 over 3 plus 4 minus 9 over 4, then minus 3. So by right, you should have 49 over 12, then k power 3. Okay, so since they tell you that it is in terms of k, so that's why your final answer was something related to k. Alright, so this will be your final answer for the A.